Good morning, students. Welcome back to the software engineering class. We have finished the 4 units of this syllabus. The fifth unit is coding and testing. And in this class, we are going to discuss about coding. What are the essential elements for a better coding? How to avoid errors in the coding? How to write what are the guidelines in writing a efficient coding? What are the importance of better coding? These things we are going to discuss in this class. Okay, as you are aware, the software development is made up of requirement analysis, then design, then followed by coding, then testing. The first two activities we have discussed so far, namely the requirement analysis and the design. Now we are passing on to the third stage, that is coding. The goal of the coding is to implement the design in the best possible manner. So the coding activity affects both testing and maintenance enormously. The time spent in coding is a small percentage of the total software cost, whereas testing and maintenance consume the major percentage. So it should be clear that the goal during coding should not be to reduce the implementation cost, but the goal should be to reduce the cost of later phases like maintenance and testing. Okay. So the goal during the coding phase is not to simplify the job of the programmer, rather to simplify the work of maintenance people and testing people. There are many criteria for judging a program, like readability, size of the program, execution time, requirement memory, and everything. So if you say readability and understandability as a clear objective of the coding activity, uh, then it can help in producing a software that is easy to maintain. So now I am going to give you some of the programming principles and the guidelines for writing a efficient code for a program. The main task before a programmer is to write quality code with a few errors in it. And also another additional constraint is to write the code quickly. Okay. So writing a good code is a skill that can be acquired only through practice. So, but some general rules and guidelines can be given to the programmer to write a better coding. Okay. So here I would like to point out some of the common coding errors committed. Memory leakage. So what is this memory leak? Yeah, memory leak is a situation where the memory is allocated to the program which is not freed subsequently. Again, I tell you, a memory leak is a situation where the memory is allocated to the program which is not freed subsequently. This error is a common source of software failures which occurs frequently in languages that doesn't have automatic garbage collections facility. So a software system with a memory leak keeps consuming memory till at some point of time the programmer may come to an exceptional halt because of the lack of free memory. So one of the main damage of this memory leak is consuming more memory. Okay, then the next one, freeing an already freed resource. Okay, this is yet another error committed by the programmers. Okay. See, this error occurs when the programmer tries to free the already free resources. The impact of this common error is quite damaging. Okay. So the impact is more severe if we have some malloc statements, memory allocation statements between the two free statements. Okay. So there is a chance that the first free location is now allocated to the new variable and the subsequent free will deallocate it. That is one of the drawback of this one. Okay. The third one is null referencing. This error occurs when we try to access the contents of your location that points to null. Okay, again I tell you, this error occurs when we try to access the contents of your location that points to null. This is commonly occurring error which can bring a software system down. And the more important point is it is difficult to detect as it is a null dereferencing. It may occur only in some paths and only on certain conditions, certain situations. Okay. Similar to null dereference is the error of accessing uninitialized memory. It is yet another problem of this null dereferencing. The next kind of error is lack of unique addresses. Okay. Aliasing creates many problems. And one among them is the violation of unique addresses when we expect different addresses. For example, in concatenating string, we expect source and destination addresses to be different. If this is not the case, we may get some runtime errors. So this is one of the problem of this unique addresses lacking. Okay. Then the next one is synchronization errors. Okay, what is this error? In a parallel program where there are multiple threads possibly accessing some common resources, then synchronization errors are possible, like multi-threading programs. These errors are very difficult to find as they don't manifest very easily. But when they occur, they can cause some very serious damages to the system. There are some different categories of synchronization errors, namely deadlock, race condition, inconsistent synchronization like this. Okay, so these things you must have studied already in your second year of Java programming or C++ programming. Okay. Deadlock is a situation in which one or more threads mutually lock each other. Okay, this you know already from your Java experience. Okay, the most frequent reason for the cause of deadlock is inconsistent locking sequence. The threads in deadlock wait for resources which are in turn locked by some other thread. Race conditions occur when two threads try to access the same resource and the result of the execution depends on the order of the execution of the thread. Okay. So when do you have this race condition? This race condition occur when two threads try to access the same resource and the result of the execution depends on the order of the execution of the threads. Okay. Inconsistent synchronization is also a common error representing the situation where there is a mixture of locked and unlocked accesses to some shared variables, particularly if the access involves updates. Okay. Then next kind of error is array index out of bounds. Array out of bounds. This error lead to exceptions. Okay. So care should be taken to see that the array index values are not negative or it doesn't exceed the upper bound of the array declaration. Okay. Then the next kind of error is arithmetic exceptions. Say errors like a divide by zero or floating point exceptions comes under this arithmetic exceptions category. See, due to this, the program may terminate. We may get some unexpected results due to the termination of the program. Okay. Then the next kind of error is off by one. See, this is one of the most common errors which can be caused in many ways. For example, starting at one when we should start at zero in the array is one such error. Okay, so if the array is of 100 size, yeah, actually the index values are starting from 0 to 99. But if you start from one, you won't have 100 locations, rather you will have only 99 locations. Such a kind of error is off by one. Okay. Then the next one is enumerated data types. See, this overflow and underflow errors can easily occur when working with enumerated types. So the care should be taken when assuming the values of enumerated data types. Okay. So we should be very careful about that. Okay. Then another kind of error is illegal use of and operator. So this kind of error arises if non-short circuit logic is used instead of short circuit logic. Okay. Non-short circuit logics will evaluate both sides of the expression But short circuit operators evaluate one side, and based on the result, it decides if it has to evaluate the other side or not. Okay, so we have to be very careful when we try to use single ampersand and double ampersand. Then another kind of error is string errors. There are a number of ways in which string handling errors, string handling functions like str, string copies, string concatenation, those functions can fail. Okay, so examples are one of the operand is null, the string is not null in terminated. Okay, so in those situations, we may get some string handling errors. The next kind of error is buffer overflow. See, this buffer overflow is also a frequent cause of software failures. Okay, its main impact is that it is a security flaw that can be exploited by malicious users for executing arbitrary code. Okay, that is one of the problem of this buffer overflow. So uh, we should be very careful about this buffer overflow. When a program takes an input which is being copied in a buffer, by giving a large input, a malicious user can overflow the buffer on the stack. So by doing this, the return addresses can get rewritten to whatever the malicious user has planned. So when the function call ends, the control goes to where the malicious user has planned, which is typically some malicious code to take control of the computer or to do some harmful damages. So we should be very careful about this buffer overflow kind of errors. Okay. So see, these are some of the guidelines for writing a better coding or some of the common errors that you commit. Okay. So how to avoid these kinds of errors? Structured programming. The basic objective of the coding activity is to produce programs that are easy to understand. So you should know that a program has a static structure as well as a dynamic structure. Okay. The static structure is the structure of the text of the program, which is usually just a few linear organization of statements of the program. But what is this dynamic structure? The dynamic structure of the program is the sequence of statements executed during the execution of the program. In other words, both the static structure and the dynamic behavior are sequences of statements. Okay. So the goal of the structured programming is to ensure that the static structure and dynamic structure are the same. Once again, I tell you what is the goal of this structured programming. The goal is to ensure that the static structure and the dynamic structures are the same. Okay. You should know that a meaningful program cannot be written without using branching statements, repetitive statements, and etc. Okay, so how is the objective of linearizing the control flow be achieved? How can you achieve that? So by making use of structured constructs, we can achieve this. In structured programming, a statement is not a simple assignment statement. It is a structured statement. So the key property of a structured statement is that it should have a single entry and a single exit. Single entry and a single, every structured statement should have a single entry and a single exit. That is, during execution, the execution of the statement starts from one defined point and the execution terminates at one defined point. Okay. So using this single entry and a single exit statements, we can view a program as a sequence of structured statements. So if all the statements are structured statements, then during execution, the sequence of execution of these statements will be the same as the sequence in the program text. So some of the most commonly used single entry and single exit statements are if then else statements, while statements, repeat statements. These are all some of the single entry and single exit statements. Okay. Then, so this structured programming is one of the guidelines for writing an efficient code. Then the next one is information hiding. Information hiding. Okay. A software solution to a problem always contains data structures that are meant to represent information in the problem domain. So that is, when a software is developed to solve a problem, the software uses some data structures to capture the information in the problem domain. Okay. So when the information is represented as a data structure, the same principle should be applied and only some defined operations should be performed on the data structures. This is the essential principle of information hiding. The information captured in the data structures should be hidden from the rest of the system, and only the access functions on the data structures that represent the operations performed on the information should be visible. For example, in a class definition in C++ or Java, only the member functions are allowed to use the data members of that class. Okay, informations are hidden. Okay, so through an object of the class, the member functions are accessed and through which the data variables can be accessed. Okay. So see, these are some of the guidelines for writing an efficient code. So in the next class, we will see about what are some programming practices for writing a coding, better coding. Okay. So those things we will see in the next class.